Hey everybody, this is Paul from SIG Service Catalog. It is February 2nd, 2017, and despite the numerous recordings that we have of SIG meetings, I realized that we don't actually have an introduction to what Service Catalog is and how the API works. So I'm going to just record something about that now with nobody watching me except Juan Vallejo. That's how you say your name, right?
Yes.
All right, excellent. So far, I'm 1 for 1. Juan it works on the user experience team for OpenShift, and he wanted to know about this, so we're going to record it. All right, everybody say thank you to Juan. Okay, so when we talk about Service Catalog, what we're really talking about is a way in the Kubernetes world to use this concept of a service broker in order to provision new instances of services and bind to them in our applications. So let me just define a service broker as something that manages a set of services, where a service could be something like a Postgres database, MariaDB database. It could be an etcd, it could be a message broker, whatever. So when we say provision, what we're talking about is like make a new instance somehow, whether that's actually starting up a new process, or maybe we have like a multi-tenant SaaS that we're exposing via service broker and we just want to make a new tenant. And when we say bind, what that means is creating possibly new, but anyway, giving us back a set of credentials, coordinates, and config items that we need to use this service. So what we are going to do for this in Kubernetes is a problem that we face in Kubernetes is that the core is really, really big. Kubernetes kind of exploded in popularity, and when that happens to a project, everybody wants every feature right now. So that has gotten us to a place where the core is really too big, and it is we're starting to get to the point where in order to really grow the project and continue to have the merge velocity for new features, fixes, whatever in the main core can like get better, is we need to start growing things outside of the core. So what that means for us is that the Kubernetes API that we build for Service Catalog is going to live in a new API server outside the core API server, and that's going to be a kind of critical thing to just know when I start drawing pictures on the board. I'm gonna highlight it, but just know that like this work is mostly happening outside of the Kubernetes core, which I think is really cool. It's groundbreaking stuff that we're not the only folks that are doing it at this point, but we're one of the groups that's kind of the pilot, which is always exciting and fun and challenging. So let's talk about Service Catalog. So the nouns in the Service Catalog space, there's only 4 of them, so it's pretty easy to talk about them. There's a broker. A broker is something that, I guess we really can't see that, can we? That doesn't show up very well. A broker is something that manages a set of services, and let's see. Sorry, things look a little weird on my monitor now, but I'm going to assume that's going to be okay. So the broker resource manages a set of services, and brokers allow us to do, basically there's 4 actions that hang off of broker. There's 5. The first is get a list of services, which in the Open Service Broker API, which is the actual API that defines what a service broker can do, there's a thing that's called conveniently, well, I say that sarcastically, inconveniently, because there's a lot of overloaded terminology in this space. It's called the catalog endpoint that tells us what services does this broker host. All right. We can also provision new instances, as we've been discussing, of a service that this broker hosts. Then we can bind to them, bind to an instance, and then unbind and deprovision. So we've got these verbs, and these connect brokers with the other nouns in our vocabulary. So the catalog endpoint gives us back a set of services, which, since we already have something called service in Kubernetes, we have to disambiguate that somehow. So we call it service class. And those of you that are familiar with how storage works in Kubernetes will note the similarity to storage class. It's actually the inspiration for this name. A service class represents a service that a broker gives us, and when we provision a new instance of it, we have an instance resource to represent that. And since this is, an important part of this is binding to binding to instances, we have a binding resource that represents our intention to use a binding in a particular application. So, as I said, all of these things, these are in our Kubernetes API for Service Catalog. And when I say the Kubernetes API, I mean like we have a particular API style in Kubernetes that folks will be familiar with if you've used the project before. The Open Service Broker API does not exactly match that style, and it doesn't incorporate the Kubernetes concepts that we need to model the stuff in Kubernetes. So the API that we're discussing right now is really kind of a wrapper, Kubernetes style wrapper on top of Open Service Broker API. To just draw that, here's Open Service Broker API. Around this is our Kubernetes Service Catalog API. So, how does this work? In terms of like, what does this API look like in terms of usage patterns? Is a question one would be asking if I told him to, but I asked it for him, so he didn't. So let's draw how this arrangement looks when we have a Kubernetes and a service catalog, and we can talk through those things in a relatively short amount of time. So you may have seen some picture like this that I've drawn on the board before, and if anybody can show me where I actually have done this explanation before, I will give you one internet thumbs up. But I went through a few of the videos in the YouTube playlist, and I couldn't find it. So we're going to go through it again now. All right. So as I said, this work is being done outside the core. So we're going to start by drawing some lines. This line on the bottom of this is Kubernetes core. On top is Service Catalog. And I'm going to draw another line here. Let's call it, maybe you're right about here. On this side is Open Service Broker API. So here is the Kubernetes API server. And here is this box is both the API server And there's a controller. Besides the controller. By controller, I mean this is the Kubernetes Service Catalog controller that implements the behaviors behind this API. So we start out, we don't have any resources created in here yet. And the first thing that happens is that the catalog operator, represented by our friend, this stick figure, here's the catalog operator. They create a broker resource that represents a broker they want to use. So now we've got this broker resource that's in the API server. The controller's got a watch on this resource, all right? And part of this broker resource is a URL that you can reach the broker at. So, just see how much time I've got here. All right, so controller has a watch on this and says, aha, a new broker resource has been persisted in the API server. I'm going to go try to reach that, that broker at the URL and do a get on its catalog endpoint. So now it's time to draw another box. Here's the actual broker process running somewhere. And this could be running inside the Kubernetes cluster. It could be running somewhere in the internet. The point actually is that it doesn't matter. As long as you can resolve this thing's URL and reach it, that's all you need to talk to it. So we do a get on its catalog endpoint. It gives us back a list of services. And controller takes this payload and transforms it into our service class resource and persists those into the API server, service catalog API server. And bam, now our catalog has the service classes that this broker is presenting to us. And so later, when another stick figure comes along, that we'll call a service consumer, they can do a get on service class and they can get back, a payload that has a list of service classes. In the future, we're going to have some kind of like curation policy around this so that an operator will be able to make a policy object that says this security principal can see this set of service classes, all right? So service consumer looks at this and they say, oh, sweet, I need a Postgres. I am going to, I'm going to ask for an instance to be created of that. So Kubernetes APIs are intention-based, and the service consumer, in order to indicate their intent that they should get an instance of this, creates an instance resource. So they're going to do a post of an instance. And this instance points to this service class. And we get that persisted in there. Controller has a watch on this resource too and says, aha, there's a new instance that's been created. I guess you can't really see it due to the glare. Maybe we can do something about this. Well, maybe I just drew this picture in the wrong place. All right, so inside the blindingly bright reflection of this fluorescent light here is a box that says instance. Controller has a watch on this thing and is like, aha, I'm gonna go to the broker that presents this service class that this instance is of. And I'm going to do, it's an HTTP put on like the provision endpoint for this thing. I'm not going to do, I'm not going to surface those details here. Say it's just provision this instance ID. And there's a whole flow for like if this takes a while to happen. So asynchronous provisioning. We're not going to worry about that now. Say that we just get back at 200 right away. Catalog sees this response and updates the status of this to say this is ready. So later when this guy, or gal as the case may be, goes in here and says get on this instance that they did, this instance's status field has a condition that says I'm ready. Now this is great. I got an instance made. Part of this payload is how do I like get to a dashboard to look at that thing if the service broker provides something like that. But I want to use it in my application. So that's where the binding resource comes in. The service consumer posts a binding into the API server. It gets persisted. Part of this thing is I'm a binding for this instance. And another part of the binding is how do I want to use this? So in our MVP, what this means for you is you get a secret, Kubernetes secret that has coordinates, credentials, config items in it that you use it, or that you need to use this instance. Long term, there are going to be some changes that we make in the Open Service Broker API to facilitate like teasing out what's a credential, what's a coordinate, and what's a config. We don't have that in the API right now, so at first we're going to just dump it into a secret. But ultimately, we'll be able to tease out services, secrets, config maps, and then to use these things in a loosely coupled way to use a binding. There's an object that we're working on, another resource that is outside of this API server. It might wind up in the core, might wind up in another API server, depending on how some things like in the mainline Kubernetes development go. But there's going to be an object called pod injection policy, which if you have watched some of the earlier videos, we called it service injection policy. Now it's going to be called pod injection policy because it's really nothing specific to services. So this contains what I want to use and how I want to use it. So same story with this resource. Controller's got a watch on this. It says, aha, there's a new binding of this instance. I'm going to do another put on the binding endpoint for this instance at this service broker. And what I get back is a payload that has the 3 C's, the coordinates, credentials, configs. And here's where I'm skipping ahead a little bit. Say all the things that that I just articulated were done. All these things that I said were coming down the pipe, say they're done. Controller is going to update the status of this. And it's going to create in the Kubernetes API server, which for those of you that didn't take your eye off the ball, I'm probably wondering, where does this come into play? All right, it comes into play now. It's going to create a service. It's going to create a secret. It's going to create a config map. And it'll create a pod injection policy. And those are created in the namespace of this binding. So what this winds up like making happen in the core is that now you've got the primitives that you need to consume the service, and you've got an injection policy that in a loosely coupled way, like with a label selector, says these pods should get this information. And that is like that's the gist of this API in a nutshell. Like I said, there's unbind and deprovision, and since I'm 5 minutes ahead of schedule, I got 5 minutes to talk about that. I'd ask if there are any questions, but this is a YouTube video, so you can come. Our Slack channel is SIG Service Catalog on the Kubernetes Slack. ask one of us questions. We're a pretty friendly group. But let's talk about Unbind. So Unbind, with an intention-based API, you're going to do a delete. So you delete this binding, and I'll gloss over the details to some extent of how we handle stuff like this in Kubernetes. We're going to delete this binding, and basically what happens in Kubernetes when you have a resource that you have to have some work to do after a user's issued a delete request, but before the thing actually gets deleted, is it's called finalization. The API server sets the deletion timestamp on this thing, and there's a list of stuff that has to run before the actual delete happens. Controller sees this, says, aha, there's a deletion timestamp on it. By the way, folks, like, I'm getting a little bit ahead of probably consensus that is surfaced in the SIG, so just note some construction codes around here. This might change a little bit, but this is my best shot at articulating what I think is going to happen now. Controller sees deletion timestamp is on here, so it goes and it calls a delete on this endpoint at the broker. Broker handles like doing whatever business logic for Unbind, and some magic like low-level details happen here. Controller says, aha, okay, it's safe to delete this thing now, and bam, it's gone. These get deleted, and now service consumer is like, well, I want to delete this instance too. I want to deprovision this thing. They do a delete of this. Same story here. This gets marked for delete. Controller sees it, calls a delete on the right endpoint at the service broker. This does the deprovision business logic, tears the thing down, gives back a 201. What's the HTTP code I'm looking for here for deleted? Gives back the HTTP code for deleted, and controller sees that, goes, deletes it, and that's pretty much how catalog, provision, bind, unbind, and deprovision work.
202.
202, right. Okay, so that's all the time I have for now. Thanks for watching, and I hope that all of you watching will feel free and welcome to join us in SIG Service Catalog. It meets Mondays at 4 p.m. Eastern, 1 p.m. Pacific time. Thanks for watching, everybody. Have a nice day.